In the spring of 1905, a storm broke out in the mind of Albert Einstein. At least that is how Einstein himself described it later in life. And the result of that storm of thinking is the special theory of relativity, a theory that completely transforms our understanding of space and time and matter and energy. I mean, Einstein found, completely counter to experience, that clocks in motion tick off time at a slower rate. He found that objects in motion are contracted along their direction of motion. He found that clocks, that one set of individuals say are in sync relative to each other, he found that if someone's moving relative to those clocks, they would say they're not synchronized. And of course, he also found the most famous equation in all of physics, E equals mc squared, establishing this deep, hidden connection between mass and energy. Now, you should say to yourself, if there is such an unexpected nature to reality that we have missed through our everyday experience, why have we missed it? I mean, why aren't we aware of special relativity right in our bones? And the answer to that is, when we look out at the universe, we recognize that there are a huge range of scales that constitute reality. And we humans only have access to a very small part of that totality. So to give you a feel for that, let's look at one axis, a length axis. And if you look at the scales that are out there in length, atoms, 10 to the minus 10 meter, viruses, 10 to the minus 8 meters, red blood cells, 10 to the minus 6, single-celled organisms, there we humans are, 2 meters, the Earth, 10 to the 5 meters, solar system, 10 to the 13, galaxy, and on to the observable universe itself. A huge range of scales when it comes to length, and we humans really only have direct access through experience to a small part of that. And that's only the axis of length. Imagine we look at the axis of mass. There too, we will find a huge range of scales, right? So if we go back and look at atoms, they weigh in 10 to the minus 26 kilograms, go down to red blood cells, 10 to the minus 15. Humans, well, depends who you're talking to, but about, 100 kilograms or so. Solar system on to the entire universe, the observable part, 10 to the 52 kilograms. A huge range of scales in mass. We humans only have direct access to a small piece of it. One more axis to look at is the axis of speed. So we humans, we walk around the world at certain ordinary everyday speeds. Sometimes we go into airplanes, but there's a huge range of speeds out there. The growth of human hair, that's pretty small. Human speed, typically, space shuttle, 10 to the 3 meters per second. Speed of light, that's a number that's going to come up a lot in our discussion, 10 to the 8 or so meters per second. The point is, in this spectrum of all possibilities, in length, in mass, and also in speed, we humans occupy a tiny, tiny part. So our experience, the experience that has given us our intuition, is built up from a very limited sense of what is actually out there. So our intuition, which really has come in some sense from evolution, right? So we evolved out there in the jungle, and our intuition got built up in order that we can survive. The survival value of understanding your environment is what matters. We humans only have access to a small piece of the totality of what's out there, and therefore it would be surprising if what we have experienced really does tell us about the physics at all possible scales, in length, in speed, and in mass. And it turns out that indeed it is the case that when you look at extremes of mass or length or speed, the world operates, the universe operates in ways that we are not accustomed to. If you are looking at extreme, say, a very small size, the new physics that comes into play is called quantum mechanics. If you are looking at extremes of huge mass, the new physics that comes into play is the general theory of relativity. If you are looking at extremes of speed, how the universe behaves at very, very high speeds, then it is the special theory of relativity that comes into play. That is what we are going to be discussing. So in a nutshell, all of the discussion we are going to be having here is focused upon how the universe behaves at very high speeds. That is the special theory of relativity.